In this video, we are going to talk about the different skills you need to know in order to successfully complete Activity 2.1. We're going to first start by quickly summarizing the different measures of central tendency. You've probably been aware of these for quite some time, but it's good to review. The mode is the least precise measure of central tendency, and it is simply the most common score. So you just simply look at all the scores, and the one that occurs the most frequently is the mode. The median is the number in the middle. So after the scores are arranged in numerical order, you find the score in the middle. That's the mode, or excuse me, that's the median. If there's an odd number, that's easy. So you just find the number that is in the middle. It has the same number of numbers on the left and the same number of numbers on the right. That middle score, whatever it is the median. If there's an even number, you find the two scores in the middle, and those two scores are going to, between those two middle scores is going to be the median. So for example, if I have a very short list of 3 scores, 1, 4, and 5, they're listed in numerical order from least to highest. The middle score is 4, that's the median. If I have an even number of scores, let's say 1, 4, 5, and 9, halfway between the two middle scores is going to be the median. So that'll be 4.5 in this case. All right, so that's the median. The most precise measure of central tendency is the mean, and this is one that we're going to be spending a great deal of time working with throughout this course. And that's why it's really important to understand what the mean is. And you have been working with the mean for quite some time, but I bet you're going to learn something that you didn't know about the mean in this video. Something that you probably did know is how to find the mean, or the mathematical equation. You simply sum up all the scores. So the sum of x, we're going to call all scores x's. If you sum up all the x's, divide by the number of scores, that will give you the mean. And again, that's probably something that you've done for quite some time, but in a little bit you're going to learn something that I bet you didn't know about the mean. Okay, now, when do we use the mean, the median, and the mode? Well, as I said in a previous video, the scale of measurement that a variable is measured on will help you determine which statistic to use. Here is the first example of that. If a variable is nominal, you're going to want to use the mode. If a variable is ordinal, you're going to want to use the median. And then finally, in most cases, if the variable is interval or ratio, you're going to want to use the mean, which again is the most precise. However, there are some limitations to using the mean when a variable is interval or ratio. If the distribution of scores on an interval ratio variable is highly skewed, in other words, if you look at the distribution and there's a lot of scores on one side and then there's a long tail on the other side, this would be, what I've just drawn is a positively skewed distribution, because the tail on the right, the tail over the more positive values, is longer than the tail on the left. That is a positively skewed distribution. If it's very skewed, the mean is going to be misleading. The same thing is true if you have a very long tail on the negative side, on the lower scores. Now, how skewed does it have to be before before the mean becomes misleading? That's something you'll gain with experience, and you'll learn that in the activity. Another situation which you can't use the mean is if you have a bunch of outliers, or even just one extreme outlier. Let's suppose you have a distribution that is appropriate for using the mean. The tail on the right and the tail on the left are about the same. But if you have, after the tail on the right and the tail on the left are about the same, you also have a number that's way away from the others. We call it an outlier. It's laying far out from the others. If you have a situation like that, then the mean will probably be misleading. Again, this is something that you'll learn, experience. How far out does it have to be? That's something that comes with experience. Okay, now we're going to talk a little bit more about the mean. As I said earlier, you probably know that the mean is equal to the sum of all the scores divided by n. That's the mathematical definition of the mean. But another way of describing the mean is, as I've said here, the mean is the value that perfectly balances the positive and negative deviation scores. Now, what does that mean? Well, first, in order to understand that, you have to understand what a deviation score is. So I'm going to go through a couple quick examples here. Here is a distribution of scores, a distribution of x's. So these are the actual scores. There's a score of 1, there's a score of 3, there's a score of 5, there's a score of 6, and there's a score of 10. The mean of all these scores is, of course, the sum of all the scores divided by n. If we add up all those scores, you're going to get the sum of x is 25, and then there's 5 scores, so you divide by 5, and so that gives you a mean that is equal to 5. Now, every score has, this is a score, 1 is a score, 3 is a score, 5 is a score. Every score has a distance from the mean of 5 that you just calculated. And that is called its deviation score. So x minus m equals the deviation. So 1 minus 5 is equal to -4. So 1's deviation score is -4. 3 minus 5 is equal to -2. 5 minus 5 is equal to 0. 6 minus 5 is equal to 1. And 10 minus 5 is equal to 5. Now we have our deviation scores. -4, -2, 0, 1, and 5. Now we can see what it means to say that the mean perfectly balances out the positive and negative deviation scores. If we look at the positive scores, we have 1 and 5. If we total them, we have a total positive deviation of +6. Now we look at the negative deviation scores. We have a total positive, or excuse me, a total negative deviation of -6. Those perfectly balance out. Of course, 0 doesn't figure in because 0 deviation score isn't positive or negative. Let's do one more example just to make sure that you get it. New distribution, so a new set of x's. The first score in this distribution is 0. The next one is 2. Next one is 6. And then 9. And then 18. Now we have to find the mean of all these scores. If we sum up all these scores, divide by the number of scores, we will find that the mean is equal to 7. So now we have to find the deviation score of each of these individual scores. So x minus the mean gives us our deviation score. Well, 0 is -7 away from the mean of 7. 2 is -5 away from the mean of 7. 6 is -1 away from the mean of 7. 9 is +2 away from 7. And 18 is +11 away from 7. Now let's do the same thing we did before. Let's total up the positive distribution, or the positive deviation scores, and we have +13. Let's total up the negatives, and we have -13. This will always work out. It has to. It's a property of the mean. Notice that in this distribution, we have more scores below the mean, lower than 7, we have 3, than we do above. That's okay. Again, the mean balances the deviation scores. It's not always the case that the mean is going to be the middle score. Sometimes it is, sometimes it isn't. Again, the middle score is the median all the time, but the mean balances the deviation scores. If the scores work out right, then the mean and the median will be the same number. But that doesn't have to be the case. All right, let's go on and do one more thing. Now we're going to use deviation scores to find a missing value in a set in a new distribution. So first I want to give you some scores. Okay, so this, what you see down here is a number line. And I'm going to place some scores on this number line. So the first score is a 3. The next score is a 3. The next score is a 3. Each x represents a score, and the location of the x tells you what this x equals. So now I'm also going to put in some 4s. There's 3 4s. And there is 1 6. This is our distribution of scores. The fact that there are no numbers above the number 5 tells you that there are no 5s in the distribution. Now, I'm telling you this, we need to find a missing score. There is one more score that I haven't put in here, and we need to figure out what that score is. And in order to figure out what that score is, I need to tell you that the mean after the missing score is added is going to be 4. After the other score is added, the mean of all 8 scores is going to be 4. And then what we need to do is find out what that missing value is after what is the 8th score. Well, we could do this using algebra, but I don't want you to do that. I want you to use the deviation scores. So if the mean of all the scores is 4, we can compute the deviation of each of the scores we have from that mean. So the way we do that, of course, is compute a deviation score. And the deviation score is x minus m. And let's do that for every single score. We have a 3, we have 3 3s, but let's do one at a time. The deviation score for 3, if the mean is 4, is -1. The deviation score for 4, if the mean is 4, is 0. And the deviation score for 6 is +2. Now, before we add things up, we got to take into account that we have 3 of some scores, right? So we need to compute the frequency. We have 3 3s. We have 3 4s. And finally, we have 1 6. So now we need to compute the total deviation. The total deviation for every score that we have. So we have 3 3s, which each have a score of -1. So that gives us -3 for that column. We have 3 4s, which are basically 0 away from 4. So That gives us 0. And then we have 1, 6, which is a plus 2. Now, as we said before, the mean always balances the positive and negative scores. Well, right now, the positive and negative scores are not balanced. We have a plus 2 on the positive side, and we have a negative 3 on the negative side. So obviously, we need one more positive deviation in order to balance out the positive and the negatives. What score, these are your scores, what score has a deviation score of plus 1? Well, 5 does. We have one of them, plus 1, and so now we have a plus 3 on this side and a negative 3 on that side, and so they balance out. So the missing score has to be a 5. All right. Now we're going to do that one more time. So what I'd like you to do is pause the video in a little bit. I'm going to put the scores in here again, put some new scores in here, and I'm going to see if you can figure this out. What is going to be the missing score if the mean of all the scores after the additional value that's missing is added? After that is added, the mean of all the scores is going to be 5. So what I want you to do is pause the video right now and try and figure this out using deviation score method. Okay, hopefully you paused and you figured this out. The answer to this is going to be 7. Now let's figure out why. Well, let's first compute the deviation score for every value. So the deviation score, if the mean is 5, is going to be -4 for 1, -2 for 3, 0 for 5, +1 for 6, and +2 for 7. Now we have to take into account the frequency, how many of them we have of each value. We have 1, 1, 1, 3, 3 5s, 2 6s, and 1 7. And now we need to find the total deviation for these. So this is going to be -4, -2, 0, +2, and +2. Notice that each 6 has a deviation of +1, and we have 2 of them. That's why we have a +2 there. So right now, we have +4 and -6. So we need 2 more plus deviations in order to balance out the -6. So what score, again, these are your scores, what score has a deviation of +2 from the mean of 5? Well, 7 does. So if we add one more 7, we're going to have 2 of those. This becomes +4, this becomes +6, and we're good to go. Does this make sense? All right. Last thing, we're almost done. Again, this video was meant to give you the skills that you need to have in order to successfully complete Activity 2.1. One of the questions that you're going to be asked, and you're actually going to be asked this many times in this activity, to explain your answer, to explain this or that, and then there's going to be a space for you to actually explain. When we ask you to explain, we want you to actually write out your answer. We don't want you to leave it blank. Explain means explain. The act of writing out your thoughts is going to help you remember this material when it comes to test time. The act of writing it out is going to make it stick. So you're going to perform better if you actually do this. Okay, so explain means explain. It does not mean leave it blank. All right. Now, the last thing I'm going to talk about is, and I've already alluded to a little bit, is what an asymmetrical distribution is. The best way to describe an asymmetrical distribution is to contrast it with a symmetrical distribution. So I'm going to create a symmetrical distribution now. The mean of this symmetrical distribution is going to be 4. So here I'm just going to create a distribution, putting some values in. There, that's a symmetrical distribution. And the mean is 4. And we can just show that it's symmetrical because the left side and the right side look the same. And again, deviation scores, we have a bunch of zeros, we have 1 plus 1, and we have 1 minus 1. And the plus ones and the minus ones are exactly in the same spot. We have 1 above and 1 below the mean. So that's a symmetrical distribution. Now in this activity, it's going to ask you to create both symmetrical and asymmetrical distributions. So I'm going to show you how to create an asymmetrical distribution. People like to create symmetrical ones because it's easy, you know. And asymmetrical is a little more challenging. And what I would encourage you to do is just, if you want to have 6 numbers in there, just throw 5 numbers in and then figure out what the 6th one has to be. And that's what I'm going to do right now. So let's say that I'm just going to throw some numbers in. I want the mean of all these scores to be 4. So I'm just going to throw some numbers in. There. So now let's figure out what the 6th score has to be. And it's going to be asymmetrical just because of the way I drew it here. So we have, if the mean is 4, 6 has a deviation of plus 2, and we have 2 of them, so that's going to be plus 4. 5 is going to be plus 1. 4 is going to be 0. 2 is going to be negative 2. Well, we have plus 5 total, and so we need negative 5 total, and so that's going to be 1 because that has a negative 3 deviation score from the mean of 4. Again, they perfectly balance out. It's an asymmetrical distribution. Okay, hopefully this will help you work through activity 2-1. I'm sure you're ready to do it. Charge.